to start off, when simplifying this, I want you to first remember that we do not have to multiply the stuff out on the top and multiply the stuff out on the bottom. The reason is because we're looking to see what is multiplied into both top and bottom that we can cancel out. And because the parentheses mean that they're being multiplied, basically I can look at each of the sets of parentheses and look for pairs that match up to cancel out. And as I do that, for instance, I see the x minus 7 here and the x minus 7 here. Notice it's exactly the same thing multiplied into both top and bottom. Because of that, I can go ahead and cancel out those x minus 7s. Now if I do that, what am I left with? On the top, I'm left with the x plus 4. On the bottom, I'm left with the x minus the 4. Now notice I didn't write the parentheses in. That's because there's nothing else that I'm multiplying by. If you did include the parentheses, it equals the same thing. So it's not like it's wrong to include those parentheses, but it's just a little bit tidier to write it that way. All right, now having gotten this far, we need to see, can it reduce even more? Well, there's a total of 4 terms here. There's 2 on top, and there's 2 on the bottom. Of those 4 terms, is there anything you can take out of all 4 of them? No. That's why it does not reduce any more past this. So when we get to this point, the x plus 4 over the x minus the 4, that's as good as it gets. And the fact that this is a plus on the top and a minus on the bottom, they're different numbers, and so we also cannot cancel out the 4s. Now in the previous problem, we could go ahead and reduce that because there was something that I could see multiplied into the top and multiplied into the bottom. Looking at this problem, I'm not seeing anything like that right away. Because as I look at all the terms, there's a total of 6 terms here. We have x squared, we have 8x, and we have 15 just on the top. Notice even just amongst those 3, there's nothing you can factor out of all 3 of those terms, let alone all 6 terms, which is what we would have to do if we were going to be able to factor it down by just pulling something out of every single term. But there is still something we can do. Because you'll notice that the top is a quadratic. If I could make it look like the previous problem, maybe there would be something we could do. And so since I have that quadratic, I'm going to try factoring that quadratic. Now do you remember how to factor something that looks like this? Give you a hint. What adds to 8 and multiplies to 15? Yeah, the 3 and the 5. And so I can go ahead and I can factor the top of this thing. It becomes x plus 3 times x plus 5. And so what I did there is I just factored the top. Our rule for factoring is that when we have a quadratic like this, that is something squared, I look to see what 2 numbers add to the middle number and multiply to the last number. And that's how I can break it down into this form here. So repeat the process with the bottom. On the bottom, notice what I'm adding to here though. Every now and then we get a little rusty on this part. We're adding here to -1. So you're looking for 2 numbers that add to -1 and multiply to -12. And so those 2 numbers are -4 and +3. So on the bottom I write it as x minus 4 times x plus 3. So there wasn't anything I could do really obviously on the top at the start. But now that I factored it into this form down here, there is something I can do. Because what do you see that's in both the top and the bottom there? The x plus 3's, yeah. And so I'm going to go ahead and cancel out those x plus 3's. When we do so, we're left with x plus 5 over x minus 4. Now, does that reduce any more? No. There's nothing I can take out of all 4 of those terms. And so that's it. We're done. And this is now considered completely simplified.